Here is the 7.8 worksheet. First one we'll start off with here is number 4. It says, what's the length of CF? I'm going to label that length X because that's what we're solving for. And you can see this is side splitter theorem. We have a segment CD here that is intersecting two sides of a triangle, and it's parallel to the third and opposite side. So that creates proportions between the split lengths of the two sides, and it also creates similar triangles. So there's a couple of different ways, just like we've talked about in class, and how you can set up proportions to solve. For this one, the easiest way is to simply say x over 40, right? X over 40 is equal to 24 over 32. 24 over 32. And then we can just cross multiply and solve. So 32 times x, 32x. 40 times 24 is, what's 96, 960. And we're just going to divide by 32 on both sides there. So that's going to give us, I believe that's 30, but let's double check. 960 divided by 32 is definitely 30. So we can say x equals 30, or we're going to say CF is 30. And that's our answer for that one. Number 5, very similar to number 4 and how you would set it up. Okay. These are all review questions 1 through 3. So go back to previous sections of videos and I covered those exact topics also in your notes. Let's look at number 6 here. If RV is 22, so right away I know I'm going to have to label. So RV is 22. The whole length there is 22. WV is 6. I'm going to label that 6. RS is 15. 15. What is the length of ST? So I'm going to label that X. Okay. So we have side splitter theorem here because we have a segment that's right there, SW, that connects two sides of a triangle and is parallel to the third side. So that creates proportional split pieces right here. So the key is I really want to focus on finding the length of RW right here because that's the only one that is left that we don't know. And I can do that by simply taking the entire length of that triangle, which is RV, and subtracting WV. So 22 minus 6, right? So if I take 22 and subtract 6, it's going to give me that length, which is going to be 16. So now I can use all that information to set up a proportion. I could say 16 over 6 is equal to 15 over x. You could also flip that and say 6 over 16 equals x over 15. That's fine. You could also say 16 over 15. 16 over 15 equals 6 over x. You can do that, or vice versa. Any of those would be appropriate. Let's cross multiply and solve. 16 times x is 16x. 15 times 6 is what, 30, 90. 15 times 6 is 90. And we're just going to divide by 16 on both sides. And I believe that is 5, but let's double check. 90 divided by 16. It is not 5. I was thinking of something else. 5.625. So we can just round it and say 5.6. X is approximately 5.6 meters. And there you go. There's our answer for that one. Let's go ahead and hop on to the next one. Number 7, what is the length of XZ? So I'm just going to go on over to the figure, XZ. Where is that? That's right there. I'm just going to label that X. That's what I want to solve for. So you can see I have what? I know this length here. I know this length here. And then this one's X, right? The only one I'm missing is XY. But we can find the length of XY taking the entire length, which is 30, right? And subtracting it and subtracting 18 from that, right? So 30 minus 18 is 12. So that tells us that XY there is 12. So now we can set up our proportion. We can say that 12 over 18, right? 12 over 18 equals x over 30. And just like we talked about, there's actually multiple ways that you could set up the proportion and still be correct. 18 times x is 18x. 30 times 12 is 360. And we're just going to divide by 18 on both sides to get that length. It should be 20. 360 divided by 18 is definitely 20. So we're going to say that the length of xz equals 20. And we don't have any units, so we're just going to leave it just like that. Pretty similar type of question here. Okay, you're actually doing the opposite here. So in number 8, I'll go ahead and add this one. We can do this one. We have time. So in number 8 here, it's saying that based on the distances given in the map above, are Main Street and First Street parallel? Well, if they're going to be parallel, then we just need to prove that the split side lengths are proportional. Right? So for example, 1.8, 2.4, 2.8, and 2.1, right? Those split side lengths of the triangle, if those are in proportion to one another, then Main Street and First Street are parallel. So we're essentially doing the converse of what we've been practicing. So we can say is 2.4, and that corresponds to 1.8. See that? 2.4 and 1.8. Is that equal in proportion to 2.8 and 2.1? So 2.8 over 2.1. So there's a couple different ways you can check. You can cross multiply both of them, and when you do, if you get the same thing, then they are proportional or equivalent. Or what you can do is you can take each one and just divide them and see if we get the same thing, right? Let's do that. So 2.4 divided by 1.8 gives me 1 1/3, 1.3 repeating. So we should get the same thing with the other one. 2.8 divided by 2.1, and you can see we do. We get 1.3 repeating for both, right? So that tells you, since they are in proportion to one another, then we can say yes, right? That Main Street and First Street are definitely parallel because we just proved that those lengths are proportional. Number 9, the diagram on the right is a picture of the sail on sailboats. All right. So lines BJCI, DH, and EG are all parallel. So these lines are all parallel. We should mark those parallel on the mark. If they tell us they're parallel, then they're parallel. Let's go ahead and mark it. Find the length of AJ. Okay, so if we're going to find the length of AJ, we're only going to focus on this triangle right here, right? Not the rest of it. So maybe I'm going to draw that separately. So I'm going to just quickly sketch it. Maybe it looks something like that. We have our line here. So we have A, we have J, I, C, and B. And this is 1.8, 2.25, and 2.5. And they want to know the length of AJ, so I'm going to call that X. So we can set up a proportion to do that. We can say 2.5 over 2.25 is equal to X over 1.8, and then solving for X will give us the length of AJ. And I think that you guys can do the rest and solve that. Just cross and multiply and solve for X. Now the next one says solve for CD. So you'll see that I'll need to include what this in triangle, that entire triangle there. You can see the triangle kind of gets larger right as we go along, like maybe that one, but we don't need that whole part. We just need it all the way here to where CD is. So I'm going to sketch that triangle. I don't have a lot of space over here, so I'm just going to kind of come down here and just kind of sketch it like that. And then we have two lines here, and they're all parallel. So I'm going to say A, B, C, D. Here's H, I, and J. And we already know that JI is 1.8, so I'm going to mark that. We know that this IH is 1.2. Let's mark that. We don't know the length of CD because that's what they're asking us. I'm going to write that in as X. BC is 2.25, so I'm going to write 2.25, and AB is 2.5. And then AJ is, well, we just solved for AJ in the last one, so I guess we're going to have to solve for that. So let's go back to that one. So 2.25x is 2.25x, and that's going to equal 2.5 times 1.8. Let's see what that is. That's 4.5. And then we're going to have to divide both sides by 2.25, so that should give us 2. So AJ is 2. AJ is 2. So now we're going to use that to solve our next problem. So now that we're on B, I can say that AJ is 2. And let's set up a proportion to solve here for the missing side length. So I'm going to use the larger triangle this time, which is, so I guess here's what I mean. There's a couple different ways you can do it. You can use similar triangles, or we can use the split side lengths. So I'm going to use actually the larger triangle, which is ADH. Let me color that. So I'm going to use this larger triangle, ADH. And then we have similar triangles. I'm going to use the smaller one as an example, as a similar triangle, because ABJ is also a similar triangle. And we're going to write a proportion. So, for example, side length AD will correspond to side length AB. And then on the other side length AH will correspond to side length AJ. So let's write a proportion that says that AD over AB is equal to AH over AJ. AD is, the length of AD, as you can see, it's just what? 2.5 plus 2.25 plus X. And that's the combined length of AD. So if I add those all together, I get 4.75. X plus 4.75. 2.5 plus 2.25 is 4.75. 4.75 plus X is just X plus 4.75. That's the length of AD. So I'm going to say X plus 4.75 over the length of AB is just simply 2.5, and that's going to equal AH. The length of AH is just 2 plus 1.8 plus 1.2, which is 5. So I'm going to say 5 over, and then the length of AJ is 2. Let's cross multiply and solve now. So 2 times X plus 4.75 is equal to 5 times 2.5. All right, so 5 times 2.5 is 12.5, 12.5. And I'm just going to go ahead and divide by 2 right here to just kind of eliminate that 2, since we're already dealing with fractions and decimals anyways. So X plus 4.75 is equal to 12.5 divided by 2 is 6.25. And we're just going to subtract 4.75 from both sides, and that'll give us our value for X, which is, I already forgot, CD, right? The length of CD over here. So I'm going to say CD equals, looks like 1.5 and feet. So 1.5 feet is the length of CD. That one's kind of a tough one, but that's what you're going to have to do. You're going to have to break down using triangles within the figure. We know that they're similar because we have these parallel lines, right? So that's really what we're looking at to solve. Make sure you guys don't forget your review questions here. Okay, you should know how to do those. Let me know if you need help with those.